Now here we derive a very important condition, that a general second degree equation in x and y to represent a pair of lines. Now this connects with the more general idea of conic sections, which we'll be dealing with in the overview of conics. That idea is that any conic section will have its equation as a second degree equation in the two variables x and y. Now here in pair of lines we have seen that the joint equation of any pair of lines is always a second degree equation in x and y. But the converse is not necessarily true. That means if we are given a second degree equation in x and y, then it will not always represent a pair of lines, because it may represent a circle, or it may represent a parabola, hyperbola, ellipse, and so on. So how do we know beforehand from the equation whether that represents specifically a pair of lines? So that means we have to consider the second degree general equation in x and y, as we know here. So for the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, the condition that this represents a pair of lines is given as a determinant equal to 0, and how to fill the determinant is like this. We have a, h, g, h, b, f, g, f, c. We know what are the values of a, b, c, h, b, c, right? So you see that this determinant is symmetric. That means if you consider the diagonal elements, then all the other elements are symmetrically located. So that helps us in remembering the elements of this particular determinant. So looking at the equation, if you get the value of this determinant to be equal to 0, then that equation definitely represents a pair of lines. Okay, so that condition we have to use. Now let us solve a sum based on use of this condition. Find P and Q if the given equation in x and y represents a pair of perpendicular lines. Okay, so now first of all let us compare it with the standard equation, and we get the value of a as nothing but p, correct, that is the x square coefficient. Then we have 2h to be equal to minus 8, so therefore clearly h is equal to minus 4. Then here b is equal to 3, that is directly seen. Then the coefficient of x is 2g in the standard equation, which is 14 here, so therefore clearly g has to be equal to 7. Then we have coefficient of y is 2f, which is 2, so therefore f is 1. And finally the constant term c is nothing but q. Okay, so we have got all the values. Now first of all we have to use another condition, that is we are given that the lines are perpendicular, right? And we know the condition for perpendicular lines is that a plus b must be equal to 0. And we have seen that the formula for finding out the angle does not depend on whether it is a pair of lines through origin or any general pair, because it only depends on the first three coefficients. Okay? So the value of a is p and b is nothing but 3 equal to 0. So therefore that gives us p to be equal to minus 3. Right? Now since this equation represents a pair of lines, we can write the condition that AG, HBF and GFC must be equal to 0. Right? So therefore let us write the values. The value of P is now minus 3, H is minus 4, so let us write right away in the respective places. G is 7, B is 3, F is 1, and now the only unknown is C, which is Q. So we have to solve it and get the value of Q. So minus 3 into 3Q minus 1, then we have plus 4 minus 4Q minus 7 plus 7 into minus 4 minus 21 is equal to 0. Right? Let us collect the Q terms, that is here we will get minus 9 and minus 16, so that gives us minus 25Q then the constant terms are 3 minus 28, so that gives us minus 25, and the last term is minus 25 into 7, so that is minus 175 is equal to 0. So therefore we get minus 25 cube to be equal to, merging the constant terms and taking on the other side, we get that equal to 200. Therefore lastly, dividing both sides by minus 25, we get q to be equal to minus 8. So in this way we have found